Hello everyone and welcome to this grade 8 physics class. The topic is measurement in science, and in today's lesson we're going to define the term density. We're going to calculate the density of solids and liquids, and we're going to see how the density of a body affects the body's ability to float or sink in a liquid. So let's get started. Consider the following figure where we have a block of sponge and a block of wood. The sponge and the wood block have the same dimensions, that is, they have the same length, same width, and same height. This means that they have the same volume. If we place the sponge and the wood on an electronic balance, the balance will clearly show that the wood is heavier. So how come two bodies having the same volume have different masses? When two bodies have the same volume but different mass, it's because they have different densities. Matter is made up of tiny particles, and to understand the term density, we need to see how these particles are arranged. So for wood, the particles are close together and regularly arranged. For the sponge, the particles are farther apart. There is more empty space between the particles. So here the two figures have the same size, they have the same volume. So in the same volume, there is more matter in the wood than there is in the sponge, because the sponge contains more empty space. So despite having the same volume as the wood block, the sponge will be lighter and the wood will be heavier. The density of a body is defined as its mass per unit volume. The term mass per unit volume means how much mass there is in a volume of 1 centimeter cube or 1 meter cube of the body. The SI unit for density is kilogram per meter cube, and another common unit for density is grams per centimeter cube. So let us look at an example of density. Example 1, aluminium has a density of 2.7 grams per centimeter cube. Again, the density of a body is its mass per unit volume, that is, how much mass there is in 1 centimeter cube or 1 meter cube of the body. So aluminium having a density of 2.7 grams per centimeter cube means that in a volume of 1 centimeter cube, there is 2.7 grams of aluminium. So 1 centimeter cube of aluminium has a mass of 2.7 grams. Pure water has a density of 1000 kilograms per meter cube. This means that in 1 meter cube of water, there is 1000 kilograms of water. Let us look at an example on how to calculate density. A body has a mass of 2000 kilograms and a volume of 40 meter cube. Calculate the density of the body. Now recall that the density of a body refers to how many kilograms of matter there is in 1 meter cube of the body. So if we find out how much mass there is in 1 meter cube of the body, we would find the density. So 40 meter cube of the body weighs 2000 kilograms. So 1 meter cube weighs 2000 kilograms divided by 40, which is 50 kilograms. Hence, the density of the body is 50 kilograms per meter cube. Now, as you can see here, to obtain the density of the body, we have taken the mass and we have divided it by the volume, which is 40. So we can use the formula: density of a body is equal to its mass divided by its volume. Let us look at another example. 136 grams of mercury has a volume of 10 centimeter cube. Calculate the density of mercury. So using the formula, density is mass divided by volume. We have the density of mercury is equal to 136 grams divided by 10 centimeter cube, which is equal to 13.6 grams per centimeter cube. So when the mass is in grams and volume is in centimeter cube, the unit for density is grams per centimeter cube. If mass is in kilograms, volume will be in meter cube, and the density will have unit kilograms per meter cube. When we are given the mass of a body and its volume, we can calculate its density using the formula density is equal to mass divided by volume. However, this formula can be rearranged to calculate the mass of a body given its density and its volume. So if you have the density and the volume of a body, you can calculate its mass using the equation mass is equal to density multiplied by volume. And if we have the mass of the body and its density, we can calculate its volume by using the formula volume is equal to mass divided by density. Let us look at a few examples. Magnesium has a density of 1.7 grams per centimeter cube. Calculate the mass of 100 centimeter cube of magnesium. So we have the density of magnesium and we are given the volume of magnesium. We need to calculate the mass. So we use the formula mass is equal to density multiplied by volume. So mass is density times volume. The density is 1.7 grams per centimeter cube multiplied by 100 centimeter cube, which is the volume, and we obtain 170 grams. Note that the mass is not in kilograms but in grams because we have the density in grams per centimeter cube. The next example, copper has a density of 9 grams per centimeter cube. Calculate the volume of 180 grams of copper. So here we have the density of copper and we are given the mass of the copper and we need to find the volume. So we use the formula volume is equal to mass divided by density. The mass is 180 grams and density is 9 grams per centimeter cube, and this gives us 20 centimeter cube as the volume. Here again we have the volume in centimeter cube and not meter cube because we are using grams per centimeter cube for the density and grams for the mass. The following exercise illustrates how we can find the density of a liquid. So in figure 1, an empty measuring cylinder is placed on an electronic balance. In figure 2, 20 centimeter cube of a liquid is added in the cylinder. The first question is calculate the mass of liquid in the cylinder. So here 80 grams is the mass of the cylinder empty. 220 grams is the mass of the cylinder plus the liquid. So the mass of the liquid is the mass of the cylinder plus the liquid minus the mass of the cylinder empty. That's 220 grams minus 80 grams and we get 140 grams as the mass of the liquid. And then the next question is calculate the density of the liquid. So we know that the density of the liquid is its mass divided by its volume. We've just calculated the mass. The mass is 140 grams and the volume is 20 centimeter cube. And this gives us 7 grams per centimeter cube as the density of the liquid. The following illustrates how to find the density of a solid. So to find the density of a solid, we need its mass and its volume. To find the mass of the solid, we place it on an electronic balance. So here, the mass of the solid is 27 grams. Next, to find the volume of the solid, if it is a regular solid, we can calculate the volume. But if it is an irregular solid, we use the displacement method to find its volume. So here we have 7 centimeter cube of water in a cylinder. With the solid immersed in the water, the level rises to 10 centimeter cube. So the volume of the solid is 10 centimeter cube minus 7 centimeter cube, and that's 3 centimeter cube. And now we can calculate the density of the solid using the formula density is mass divided by volume. That's 27 grams divided by 3 centimeter cube. And this gives us 9 grams per centimeter cube. When an object is placed in a liquid, the object's ability to float or sink depends on the object's density and on the liquid's density as well. If the density of a body is less than the density of a liquid, then the body will float in the liquid. On the other hand, if the density of a body is greater than the density of a liquid, the body will sink in the liquid. So in this figure here, body A is floating in this liquid, whereas body B sinks in the liquid. This means that the density of body B is greater than the density of the liquid. That's why it sinks. The density of body A is less than the density of the liquid. That's why it floats. Here are a few daily life examples. This boat is floating on seawater. Now this means that the boat's density is less than the density of seawater. Liquids as well can float or sink in other liquids. For example, cooking oil, which is a liquid, floats on water. This means that the oil's density is less than the density of the water. Steel is a metal which is a solid. Seawater is a liquid. And in general, if we compare the densities of solids, liquids, and gases, solids are more dense than liquids, and liquids are more dense than gases. This is because in a solid, the particles are very close together, meaning there's more mass per unit volume. In a liquid, the particles are further apart. There's more space between the particles, so there's less mass per unit volume. And in a gas, the particles are very far from each other, so there's very little mass per unit volume. Hence, solids are more dense than liquids, and liquids in general are more dense than gases. Among solids, metals are the most dense. So if a metal like steel is more dense than a liquid like seawater, how come a boat made of steel can float? To understand how a metal boat can float, let's look at these two bodies here and let's calculate their densities. The first one is a block of steel of mass 16,000 kilograms. Its dimensions are 2 meters by 1 meter by 1 meter. So 2 times 1 times 1 equals 2. Hence, the block has a volume of 2 meter cube. So its density is 16,000 kilograms divided by 2 meter cube, and this is equal to 8,000 kilograms per meter cube. This is the density of steel, which is greater than the density of seawater. Therefore, this block of steel will sink in seawater. On the other hand, this block of steel is hollow, so it is empty inside, which means that its mass is much smaller, although its dimensions are the same as the first block here. So it has the same volume as this block of steel, 2 meter cube. However, its mass is much smaller because it is hollow inside. So if we calculate its density, it's 1500 kilograms divided by 2 meter cube, and this is equal to 750 kilograms per meter cube. So now this hollow block of steel will float on seawater because its density is much less than that of seawater. So the fact that it has been hollowed out has decreased its mass and decreased its density, so now it floats. So although it is made of steel, which is more dense than seawater, the density of the structure as a whole is less than that of seawater. And this is how a boat made of metal can float on water. So there you go, we have reached the end of this presentation. Thank you for your attention.